In this problem, we're given a triangle with points at 1, 5, 1, negative 2, and 5, negative 2. And we want to show that this triangle satisfies the conditions of the Pythagorean theorem, which are a squared plus b squared equals c squared. So we need to find the lengths of each of these sides, and we're going to do this very carefully, right? So the length of A is the distance between 1, negative 2 and 5, negative 2. So we're going to do it the square root of x2, 5, minus x1, which is 1 squared, plus the second point in the y, which is a minus 2, minus the first point in the y, which is also minus 2 squared. Right. Now, doing these subtractions first, 5 minus 1 is 4, so we want to square that. 2 minus a negative 2, we can flip that, right? Minus a negative is the same thing as adding a positive. Plus 2 minus 2 is 0. So we're going to get the square root of 4 squared plus 0 squared, which is the same thing as the square root of 4 squared. So A is equal to 4. Right? So this side is equal to 4. To get B, we can do a similar type of thing, right? Well, I'm going to go bottom to top, right? So x2 I'm going to call 1. x1 I'm also going to call 1, so that's squared, plus our y's, right? We have a minus 2 minus 5 squared, right? So b is equal to square root of 1 minus 1 is 0 squared, which doesn't give us anything. Minus 2 minus 5 is a minus 7 squared. Minus 7 squared, negative times a negative is a positive. 7 times 7 is 49, so the square root of 49. So b is equal to the square root of 49, or 7. Okay? Right, now the last one to get is c. Right? So c is going to be equal to the square root of, I'm going to go from 5 to 1 here. So 5 minus 1 squared plus minus 2 minus 5 squared. Extend that out. Right, now doing these subtractions, 5 minus 1 is 4. We have to square that, plus minus 5 minus 2 is minus 7. Again, we need to square this. 4 squared is equal to 16. 7 squared we saw before was equal to 49. 16 plus 49. 9 plus 6 is 5. Carry the 1. This is 65. Now, this is, it's what it is. So C just is the square root of 65. All right. Now, we need to show that this thing satisfies the Pythagorean theorem, a squared plus b squared equals c squared. Okay. Now, let's look at these pieces. A squared is 4 squared. B squared is 7 squared. All right. Well, 4 squared is 16. 7 squared is 49. 16 plus 49 is equal to 65. And is 65 equal to square root of 65 squared? Yes, 65 is equal to 65. So we are good.